The discriminant. What is the discriminant? The discriminant is a useful equation that allows us to determine the type and number of solutions. Now, the discriminant is simply just a piece of the quadratic formula. The discriminant is the portion of the quadratic formula underneath the square root symbol. So the b squared minus 4ac, which is underneath the square root symbol in the quadratic formula, is our discriminant. So our discriminant is equal to b squared minus 4ac. The question is, what does that tell us? Why is it useful? So what does the discriminant tell us? The discriminant tells us the number and type of solutions we expect to get if we were to solve the quadratic equation that we were working with. So there's three different scenarios. The first scenario here is if the discriminant b squared minus 4ac is greater than 0, then you have two real solutions. We can see that that's the case because if the b squared minus 4ac is greater than 0, that means you have a positive number under the square root. Positive numbers under the square root give us real solutions, and two real solutions. Now the next situation is if the discriminant b squared minus 4ac is equal to 0. If it's equal to 0, then the piece under the square root is 0. Square root of 0 is 0. So the plus and minus 0 doesn't do anything different for the two potential solutions, which means that you end up with only one real solution. The last case is if b squared minus 4ac is less than 0. In other words, negative. If you have a negative underneath a square root, we know that that produces complex solutions, and complex solutions in quadratics always come in pairs. So we would get two complex solutions if the discriminant was less than 0. Let's take a look at a few examples to illustrate this. So we have a first example right here. First example is 0 equals 3x squared minus 4x plus 6. What we want to do is we want to calculate the discriminant and state the number of and type of solutions expected. So our quadratic here is already set equal to 0. So I know from this that my a value is equal to 3. My b value is equal to negative 4. And my c value is equal to 6. Now the discriminant, as we've seen, is calculated by doing b squared minus 4ac. So we have b squared minus 4ac. Our b value is negative 4, so that's negative 4, put that in parentheses, squared, minus 4 times a. We've already seen that a is equal to 3, and 4 times a times c, and we can see that c is 6. So simplifying this produces negative 4 squared, which is positive 16, minus 4 times 3 is 12, times another 6 is 72. And 16 minus 72 gives us 56. Or negative 56, that is, because it's 16 minus 72, a larger number, so negative 56. So our solution to the discriminant is a negative number. If we get a negative, that's less than 0, for a discriminant, we know that we will end up, if we were to solve this equation, with two complex solutions. There we go. Let's do another example. So we have another example up here. X squared minus 7x plus 8 is equal to 5. What I'd like to do first, in order for the discriminant to give us an accurate result, is to set our equation equal to 0. So that means I need to subtract 5 from both sides before I do anything else. That produces x squared minus 7x plus 3 is equal to 0. Now that my quadratic is set equal to 0, I can calculate my discriminant accurately to determine the number and type of solutions. So x squared minus 7x plus 3, my a value is equal to 1, my b value is equal to negative 7, and my c value is equal to 3. So our discriminant, which is calculated from b squared minus 4ac, ends up being, that's going to be a negative 7 squared, minus 4 times a, which is 1, times c, which is 3. So with those values plugged in, we can now calculate the discriminant. So negative 7 squared is 49, minus 4 times 1 is 4, times 3 is 12. So that's 49 minus 12, which produces a value of 37. 37 is a positive number. According to what we saw about the discriminant, if your discriminant is greater than 0, otherwise a positive number, we know that it ends up producing 2 real solutions. So if we were to solve this quadratic, we know that we should end up with 2 real solutions. Very good. So let's do one last example. So we've got another quadratic equation here, x squared minus 4x plus 5 is equal to 1. Again, we need to set our equation equal to 0 in order to accurately calculate the discriminant. So I need to subtract 1 from both sides. That produces x squared minus 4x plus 4 equals 0. So again, now that my equation is set equal to 0, I can calculate the discriminant. Our a value is equal to 1, our b value is equal to negative 4, and our c value is equal to positive 4. So again, our discriminant, which is b squared minus 4ac, I can go ahead and plug in my a, b, and c values into that. My b value is negative 4, so that's negative 4 squared, minus 4 times a, which is 1, times c, which is 4. Simplifying this, we have negative 4 squared, which is positive 16, minus 4 times 1 is 4, times 4 is 16. So we end up with 16 minus 16. 16 minus 16 produces a result of 0. Result of 0. And we know that from above, if our discriminant is equal to 0, not greater than 0 or less than 0, but equal to 0, that it ends up producing a result that if we were to solve this, we would end up with 1 real solution. Not 2 real solutions, only 1, and it would be a real solution. So in summary, the discriminant, first off, calculates the value underneath the square root sign. And what that does for us is it tells us whether or not we expect 2 real solutions, that is, the discriminant is positive, 1 real solution, that is, the discriminant is equal to 0, or 2 complex solutions. That's a result from the discriminant being negative.